Hello and welcome to another Linz Meetup. Thank you for joining us here virtually to our 35th Meetup. We are looking forward to two very interesting talks today. We have two guest speakers we are thrilled to have you and to have our guest speakers. My name is Rainer Strobek and I will lead you through this evening, and we will start, as it's tradition here at the Linz Meetup, with a round of community news so you know what's currently going on in the IT community here in Linz and around Linz. Let me share my screen with you. I've prepared just a few slides that I will use to lead you through the beginning of this meetup. So the Linz Meetup is, as you probably know, brought to you by the Coding Club Linz. The Coding Club Linz is a volunteer-driven programming club. I have the honor to be chairman of this club. We are running multiple communities. Our largest project is probably the Coder Dojo Linz, which is a programming club for kids, but we run additional events and meetups all around the year, and the Linz Meetup is obviously also one of the most important things that we do and that we really love. Now, today's speakers are Ivan and Carl. We are looking forward to two very interesting talks. Ivan will kick off the evening with a talk which is with the title "Moving Quick with Rust, Not an Oxymoron." We are looking forward to having Ivan as a speaker. And then we have Carl, who will present 9 rules for creating fast, safe, and compatible data structures in Rust. Let's start with the community news. I forgot one thing. Let me point out that we have a Discord server. It's not very active, but it is a good way to get in touch with us. So if you have questions about Linz, or if you want to talk about a proposal for a talk or something like this, the Discord server is a great place to get in contact, to get in touch with Stefan and me. Here you have the link. If you would like to join, this is the link. Now to the community news. The first community news is our very own Coder Dojo Linz. As I said, Coder Dojos are programming clubs for kids, and the next programming club for kids will be this Friday. It will be our Christmas event. It is an online event. We have bi-weekly in-person events. Last week we had both online and in-person, and this week is a pure online version. So if you have kids, nieces, nephews, whoever who is between 8 and 17 years and who can speak German, they are all invited. We will implement an Uno card game this week, so we will definitely have a blast. It will be a lot of fun. The next entry in our chapter concerning community news is Female Coders. Female Coders is a community of women and girls who either are in IT technology or who do want to start in IT technology. And we do a lot of work with them. They are an awesome community and they have regular study groups. You can find the details about their study groups here at this URL. And I looked up the next event. The next event will be at the end of January. On 24th January will be the next study group for women and girls. Definitely check them out. They are a very important cornerstone of the IT community here in Linz. The next one is a meetup from our friends at the Cloud Native Community Meetup. They will also have their next meetup on the 24th of January. As far as I saw, at least the last time I checked, the topics were not announced yet. It just said to be announced, but this is a save the date. If you are interested in cloud native technology, then definitely check them out. Here you have the link. If you miss one of the links, feel free to quickly drop a message in the YouTube channel, and I'm happy to share either the slides or the link that you are missing. The next one is probably the most well-known meetup that we have here in Linz. It's one of the oldest and most established meetups, the Technologieplauschel. It will happen at the end of January, the 13th of January, and the program has also been set already. You see it here on the screen. Definitely check out technologieplauschel.at. You will find the details about the times and the location and so on there. The last piece that I would like to present here at the community news is one thing that we are particularly proud of. You know, communities are very important for our club, for our team here, and it warms our heart when we see that young people are also starting and engaging in community. And currently we have a group of 3 enthusiasts. They are just, I think, 17 or 18 years old. They are from the HTL Leonding, which is a vocational college for computer science, and they are so passionate about Linux that they decided they want to start their own their own Linux meetup directly here in Linz. There are some Linux meetups around Linz, but not in the city of Linz. And it's really awesome that young people start with new communities. They are passionate about something. And of course, it's our honor to help them getting started. So this is a very big shout out to everybody out there who is also passionate about Linux. If you would like to present at their new meetup a topic around FOSS, around Linux, please check out. Here is the meetup link. They have a link there how you get in contact with them. You can also send me an email and I will put you in contact with those guys. If you would like to watch the meetup, if you would like to visit the meetup, please subscribe at meetup.com to their event. It definitely will be a great extension to the IT community here in Linz. So this is something new. The exact date has not been finished yet. It is very likely that it will be the 18th of January, but this has not been fixed yet, but it will be at some point in January. So crossing fingers for the friends here at the Linux meetup that they will have a good start. I am absolutely sure they will. And it is, as I said, an honor for us that we can help to get this meetup started. That was the round of community news. That's all I wanted to tell you. And with that, I will stop sharing my screen and I will ask Ivan to come to me on the screen. Hey, Ivan.
Hello, Rainer.
Hi, how are you?
I'm doing good. Those are some great community news. It makes me miss Linz already.
Yeah, absolutely, absolutely. Ivan, because you just said it makes you miss Linz. Where are you currently? Aren't you in Linz?
No, I'm back in Croatia now for the holidays.
Ah,
Yeah.
nice. Do you have snow there?
No, I escaped the recent Linz snowfall almost on
Yeah,
time.
absolutely. A few weeks ago, we had a lot of snow, really a lot of snow, but now snow is already melting. Very nice, very nice. Ivan, we are very much looking forward to your talk. Are you ready to get started?
I am, and I just want to say a disclaimer, which I told you already in backstage. I'm at home right now. The setup is I don't even want to turn the camera around, but I have like layers of screens. My microphone fell in my lap because there's not enough space on the table. So I'll try to look you in the eyes as much as I can, but I cannot promise anything.
Ivan, given these circumstances, we are double as proud to have you, that you take the time, even if you're in your holidays, in this very special setup. Stefan and I always joke that those talks where we have the worst surrounding factors, where we create something last minute, or where it's really hard to present, those talks are sometimes the very best talks, because yeah, you're on the edge, on your toes, and sometimes these talks are legendary. So I'm pretty sure that this will be the case with your talk.
Let's see, Rainer, let's see.
Let's see. Okay, do you want to share your screen, or do you want to
Yes.
start without screen sharing at the beginning?
No, we can start with the screen
Okay.
share. Let's
Perfect.
hope it works.
Yep.
There we go. Should be up.
There we go. I will put it on the stage now, and we see your starting slide. Ivan,
Amazing.
as I said, thank you for taking the time. Thank you for presenting here at Rust Linz. The stage is yours. We are looking forward to your talk.
Thank you, Rainer. Appreciate it. Cool. Hello, everyone. It's a pleasure to be here again. Thank you to everyone who helped in backstage to get things going. My talk for today is called Moving Fast with Rust, not an oxymoron. The reason why I went with that title is because I feel like there are some seeds that were planted a couple of months ago or even years back that tied the mention of Rust was slow. Whether that's slow to learn, slow to build, doesn't matter. And I think that we are not doing it enough justice. So I've been in Rust for a bit over 2 years, and seeing the evolution of various segments over time gives me hope that we are going in the right direction. Like, there's lots and lots of educational content being created. Various documentations are becoming more adequate. If you remember, back in the days, everyone just had like the default docs RS setups for their docs, which are maybe not too adequate for beginner learners. There's lots of events being organized to promote Rust, but also to bring it closer to people who think Rust is not there yet. Rust Linz is also one of them. I love Rust Linz. But without further ado, I want to introduce myself real quick by sharing a detailed timeline of my major life events. So we can start with the first one, which is 1996, which is when I was born. And then we moved to 2023, which is when I moved to Linz. And this pretty much sums it up. I always like to joke how starting in Rust eventually led to me actually moving to Linz, one of the most popular Rust cities. And well, Stefan did a very good pitch back in the days when we were considering moving to another place. So thank you for that, Stefan. Cool. The jokes aside, I'm originally from Croatia, as we said in the beginning. I'm leading DevRel efforts at Shuttle. Shuttle, among other things, will be using it in today's demo to demonstrate how fast you can go from zero to a deployed app. For those who don't know, Shuttle is a cloud development platform which allows you to focus on moving quickly and writing good code. The way it does it is by extracting the infrastructure layer. And in short, you add an annotation or two, you get a database or another resource, and then you're just one CLI command away from your app going live. As you might have guessed, I'm passionate about Rust. And the more time I spend at my laptop, the more I try to like counterbalance it by spending time in nature, mountains, and outdoors in general. And another fun fact about me is that I type very fast. If anyone wants to challenge me, you can shoot me a DM on Discord, which I'll reveal in the links at the end. Anywho, what's the goal of this talk? It's simple. I want to showcase how to move fast with Rust with a simple example and do a shameless plug since I work at Shuttle. And what we're going to do is we're going to build and deploy a minimalistic journaling app. We will be using Ascama for the front-end template, or well, as the template rendering engine. We will use Shuttle's Postgres plugin for provisioning the database. We will use SQLX for interacting with the database, and in the end, we will use shuttle to deploy the app. Without further ado, I will switch my screen over to the IDE. Let's see if it works first try. Again, if you see my forehead, it's because the setup is really messed up. Cool. VS Code should be in front of you right now. Let me just adjust my setup. Cool. If you see me doing weird things like this, like making the terminal double the screen height, it's because half of my laptop is covering the external screen. Cool. We are going to start off things by utilizing shuttle's init command, which will ensure generate a project that contains all the dependency needed for us to be able to get the resources, but also to ship it. This cuts down on time that we would otherwise need to spend. So I write cargo shuttle init. It asks me for a project name. For this demo, we'll go with journal-Rust Linz. We will use this directory. For this example, we will pick Axum, which I assume doesn't need an introduction, given that it seems to be the most popular framework out there. And we will start a project container on shuttle. Cool. So some files have been now generated. We have a main.rs file, which you can see here. It's pretty simple. It's just a hello world. It has one route, which is the root route, and it shows hello world. So what I want to do now is show you some of the dependencies that were generated with the initialization. We have Axum, we have Shuttle Axum, which is a plugin that allows us to use shuttle. Axum, the shuttle runtime. We have Tokyo, and we have tracing. Now, I want us to quickly deploy this just so we see what we get. I'll run cargo shuttle deploy AD. The AD stands for allow dirty, which means that we are not committing any files and we just want to deploy it. And now you'll have to excuse me for a second to rearrange my setup so that I can see what's going on in the terminal. Again, small table problems. And I will create a new terminal tab because I want us to start adding dependencies while the Hello World app is being deployed. So we'll start off by adding SQLX, which again, we will use to interact with the database. We'll add features like the Tokyo runtime, Postgre, and Chrono. We will add the shared DB plugin from Shuttle with the feature flag Postgre. We will add Chrono with the feature Surdy. We will add Surdy with the feature Derive. And finally, we will add Ascama Axum 0.3.0 with the feature flag Ascama / with Axum. Okay, rearranging my setup. I hope that the microphone moving it didn't change the way my voice sounds, but now we have pretty much most of the dependencies we need to get started. Let's check back in with the deployment. It's compiling. It shouldn't take too long for it to wrap up. What Shuttle here is doing is it's packaging up the code, it's provisioning the resources, and what it should return us in just a few seconds is a URL of our app being live and deployed on a shuttle app.rs domain. So it should be up. Deployment crashed. Database is locked. Okay, I need to do a quick run again. This is something that sometimes happens when there are simultaneous deploys. Given that I was experimenting earlier, this might have triggered it, but this shouldn't take too long now to redeploy again. Okay. Well, while it's deploying again, we can go into writing some code, and we will check back in it in just a couple of seconds. Anywho, we will now first add a struct which holds a database connection, the PG pool, which is provisioned by shuttle. We will do that by writing down. So first we will use derive clone, and then we will call the struct app state, make it public, and note down db pg pool. Cool. It tells us it cannot find it, so we will quickly import it. Okay. So just for explanation, deriving clone is a requirement, as in order to add this as an app state to the Axiom router, the trade bound requires it to be cloned. Otherwise, we would need to wrap it in Arc, which essentially being the same, but it's a bit less pretty, and we care about it being pretty. Then we can add the database macro to our main function, and we will also add, just a second. So let's add the macro first. So shuttle, shared DB, Postgre, DB, PG pool, and then do a quick DB execute, include migrations.sql, data-await, data-unwrap. This will probably give us an error. It will tell us that there is no migrations SQL file, which we will create right now. Migrations.sql. It'll be fairly simple. So create table, if not exists, entries, ID. We'll have a title. We'll have a body, and we'll have a created at. Cool. This should do the trick. Okay. So that error should be gone now. Cool. There's one more. It's the executor. Let's just quickly import this, and we should be good. Okay. Good. We have that. So let's now declare our app state struct. So let's do, it's difficult with the font size at 300%, but let's do state, app state, db. And let's also add it as a state to the end of the router. Let's make it a bit cleaner. There we go. Cool. Okay. In the meantime, our hello world seems to be up. Let's do a quick curl to check it out. So journal rust.linz.shuttlelab.rs, and it returns hello world. Cool. So our hello world is up. Let's just see what this is complaining. The copy trait. Why are you complaining? Let me just double check something. DB, okay. If anyone sees something that I don't see, feel free to jump in.
Ivan, we have one suggestion, state.db.execute instead of db.execute. I'm not sure if that helps.
Huh. That's odd. Okay. Thanks for the suggestion. Let's see where we end up with. This was odd, but again, thank you. Cool. Okay, this fixed. Thank you for the help from the audience. We will keep moving forward since I've lost some time on debugging this, and we will declare the structs that implement the Ascama template, as well as our post submission struct type and the fields for the journal post itself that we will use. To save on time, I'll just quickly copy paste them over and go through them. So we will quickly copy paste the dependencies and drop them here. So chrono, naive date, sorted to deserialize, and Ascama templates. I'll quickly pick up and drop the structs. Hit save. It'll probably be red. Okay, so we do not have the templates that we will need to use for our journaling app, and it's making it clear for us. So we don't have the template post index HTML, we don't have the post form, we don't have the post. Again, in order to save some time, what I will do is I will just drop the HTML templates over to our folder. There we go. So I'll drop this here. No. Okay. Templates. There we go. So just briefly on what this is, these are the templates for the journaling app, the base template, the post index. If you ever worked with a template rendering engine, you're probably familiar with the syntax. Again, this is Ascama. It's based on Jinja, if I'm pronouncing that right, which is a template rendering engine from Python. And pretty much what we're trying to do here is we're trying to insert the entries into the HTML. We are doing a loop for post and posts, and then listing out all the journal entries. And of course, the most important part, we have some CSS here, which I really hope will look at least decent in the end. But yeah, errors gone, issues fixed. We need to create our Exum function handler, our Exum function handlers, and we will create a handler function for getting all entries, getting an entry by ID, and an endpoint for creating the entry itself. I'll quickly import Ascama Exum into response, and I'll cover that in a bit. So first we will do get entries. We will do get entry by ID. It's fairly simple. We'll do create entry and then finally the entry form. So what we did here is in each one, we are passing the state that we provided to Exum to handle the database connection pool, as well as extracting parts of the request with Exum's extractors, state being an example of one of those. The path and form extractors are also another two examples of extractors that we need to use. In each of these functions, we need to use an SQL query, which you can see here, to interact with the database and then return a response based on what is returned. Keep in mind that some extractors, like form and JSON extractors, they consume the HTTP body, so they need to be used last. Cool. We are almost at the end of building the application, we will create just another route, which we will use to get the CSS working. So we will call it as simple as it can be. We will call it styles. It implements axiom response. We will create a new variable called styles. It will read to string from template styles.css, unwrap because error handling or the lack of it. Response builder, we'll do header, content type, text CSS, body styles, and then unwrap again because lack of error handling. And the final step that we're missing here is okay. What happened here? Let's see. Post not found in directories, journal, and templates. Why not? Okay, that's why. So let me fix that real quick. Okay, this should be resolved. Okay, we have some errors, which are just missing imports. So we'll quickly click through them and make sure that they are all sorted out. Okay, so this is the axiom extract path. We need to implement this, the form. Don't hate on me for using the mouse for clicking through these things rather than the keyboard. Response, axiom. Okay, we are out of errors, happily, luckily. And again, let's get rid of this. We don't need this anymore. Let's do the router. So we can remove this one. We don't need it anymore. Let's do root, get entries. Let's do entries, which will be a post method for creating an entry. Let's do entries create, which will be get from the entry form. Let's add the ability to retrieve by ID. And get entry by ID. And let's add the route for our styles. And this should be it, hopefully. Post, there's an error, probably missing import, and import added. Cool, this should be it. The moment of truth, will it run? We will quickly do another deploy. We'll run it. Okay, this is not the deploy command, but I don't see the deployment command. There we go. Okay, so let's see what happens. If all goes well, I will successfully change the window I'm sharing to the browser, and we should have our journal app up and running. Okay, cool. Everything is up. We also have our connection string for our database. For the database that was provisioned by Shuttle, we have a URL. And let me quickly switch over to a browser. And I won't spoil the surprise, but it's not working. So you can see what's happening. Window. So we have an error from the database. Column created at doesn't exist. Why doesn't it exist? Because I did a typo and I named it create at instead of created at. So I'll quickly redeploy, and in about 10 seconds, when I refresh the page, everything should be working. So let's pray to the demo gods and let's see what whether our prayers will be answered. Okay, let me refresh it. Still not working. The demo gods have spoken. Let me try a quick fix. Let's deploy again. Okay. So I think this has to do with this part here. I'm not sure if I remove this, will it be better? No, it's still the same issue, which is odd because in the run-up, everything seemed to be working, and I even reverted to copy-pasting some of the code. But for some reason, it's not going through.
Ivan, we still see only the browser with the output of the database column, the missing one. I'm not sure if you want to share something else. And we have a suggestion from Arcus. Maybe you have to remove the table from the database to make sure that it is recreated, because that's just an idea.
Yeah. To me, it seems like I hate when it comes to debugging in a live demo. Hang on, let me just check something. I'll open up the repo. I know I'm still sharing the browser. I'll just do 30 seconds of checking something out, making sure that I haven't done. Okay. Actually, no. Migrations SQL. Migrations SQL. Okay. Yeah, seems like this did the trick. And if I redeploy now, so I'll explain a bit what I did. But if I refresh my browser, things should be working in a second. Okay. And it's not working, which means that the demo gods have been without mercy on me today. Unfortunately, what we can do is, Rainer, if you want to come on stage, I can wrap up the talk in a bit and then do some background fixing. Hopefully, after Carl is done, I can do a quick demo of the app and do some closing lines.
Absolutely, that's absolutely no problem. Hey, we are here at a meetup, and somebody who is as brave as you doing some live coding and putting everything from scratch together, something like this can happen. We have done that. Everybody has done it like that. Even before we wrap up, can I ask you one question, one particular question, which got asked during your presentation? Arcus has seen that you are currently using Axum 0.6, and recently
Yes.
Axum 0.7 came out. So he asks, does Shuttle support Axum 0.7? Because, as I said, you are currently using Axum 0.6.
Yes, that's a great question. We do support it. The problem is that in order to play it even more safe, Axum 0.7 was released recently. As you might have seen earlier, I'm also running a bit of an earlier shuttle version just to try and make sure that the demo goes smoothly. But I guess it has bitten me in ways I haven't imagined it could bite me. But yeah, but great question.
So Currently, it is supported, but yeah, okay, perfect, yeah, wonderful. Um, I think you made a great point that with serverless platforms like Shuttle, it is much easier to get Rust applications running. Of course, you need some debugging, no question about that. But you, in your introduction, you were particularly also talking about the speed with which developers can learn Rust. I recognize that you are using I think two AI tools. I think I saw GitHub Copilot and I also saw Tab9. What do you think is the role of AI tools like GitHub Copilot or Tab9 for developers who get into a new programming language like Rust, which is not particularly trivial. It's not a simple scripting language. Do you think that AI tools like that make it easier to get started or to switch between languages?
That's a simple but tough question. What I mean by that is, I think that AI assistants, like Copilot, for example, are helpful with keeping you on the right track in some cases when you're coding something. What I mean by that is they can pre-fill some recurring actions that you continuously do, at least from my experience, and make your life easier. Whether they will make learning a language easier, especially with Rust, I'm not sure. You will get some suggestions. You might not understand them at the beginning, and to me, it feels like when you're trying to learn a language, for example, using ChatGPT or something, it is very easy. It is helpful, I agree, but it's very easy for it to confuse you in ways you might have not been confused when you've learned from scratch. I think it's a great assistant as long as you treat it with some sort of, what's the word I'm looking for? Um, if you treat it with caution, you know,
Mhm.
don't think of it as a tool that will solve all of your problems.
Mhm. Yeah, thank
By
you
the way,
for this.
if you want to bring my screen back up, I had a
Absolutely.
slide. I had a slide ready for for if the demo fails. And I just wanna, yeah, okay. So this is in case the demo succeeds. But I want to just say a couple of more sentences before we
Please.
go over to Carl's talk. Um, the goal was to show how quickly we can initialize a new project, use the framework of our choice, given that most of the frameworks are supported, set up the templates, provision a database to store all the journal entries, package it up, and ship it within like 10 to 15 minutes. I know this is a very basic example that doesn't require a lot of effort or you know any word you want to put there, but it brings hope, quote unquote, and it shows how Rust has evolved over time, how the tools are catching up. Because the way I started off my talk was people still combine it with the keyword slow. But I think that if I'm not going to come in with a hot statement that Rust is quicker than its alternatives, but I'm going to come in with a hot statement that people who are or were critical of the speed and efficiency of Rust to give it another go with all the latest toolings, libraries, and so on and so forth. It is easy to give Rust a go a year or two back and not be too happy with it, with the resources, like documentation and similar, with the state of it, the ecosystem, with the libraries, with the frameworks, and so on and so forth. And I'm saying this because I think that the whole ecosystem is really getting together, trying to become the enablers in getting people to use Rust instead of just love it. And what I mean by that is it's a reference to the Stack Overflow survey, which tells us that Rust is for X years in a row the most loved language, but it's also contrasted by the fact that it's not used as much as people want it to be. Yeah, that was the conclusion. I have a couple of links here in case anyone wants to follow me or Shuttle. You can follow me on Twitter. You can check out Shuttle at shuttle.rs. You can check out the Launchpad, which is something we're doing together with Stefan Baumgartner, which is one of the best ways, in my opinion, to learn Rust because it's a newsletter, bite-sized chunks of information fed into you, and you can do it at your own pace if you're busy, if you're not busy. And finally, if you want to join our community, you can do so at discord.gg. /shuttle. And I think that wraps it up, Rainer.
Perfect. Thank you very much. Thank you, Ivan. And if you still have the nerves to do some debugging and you want to show us the final running sample at the end, absolutely no problem. You can come. We would love to welcome you on stage after Carl's talk, and you can show us the application running in Shuttle.
Sounds
so
good.
If you want, we can always do that. Absolutely no problem.
Cool.
So thank you very much, Ivan. Thank you. I will quickly check if we got additional questions. No, people were actively watching and making suggestions. I already also showed these suggestions. So people enjoyed very much that you did this live presentation. And with that, I would like to say thank you again. Thank you and goodbye for now. Maybe we'll see each other at the end of the meetup again. Okay?
Sounds good, Rainer. Thank you for having me.
Thank you. See you later, Ivan. Bye.
Bye.
And with that, I would like to bring Carl on stage.
Hello.
Hi, Carl. And we make a large jump from Europe to the United States. Carl, where are you currently located? Where are you broadcasting from?
I am in Redmond, Washington, on the west coast of the United States. And I told you before it was raining, but now it's actually cleared. So with the dawn, we get some nice weather today.
Very nice. So it's still morning with you, I guess, in your time zone, right?
Correct. 9 a.m.
9 a.m. For us, it's 6 p.m. in the afternoon. So very nice. Carl, thank you very much also to you for taking the time. We are really looking forward to have a contribution from you to Rust Linz. We always value that very much. Can I already share your screen? I think your slides are already up, right? Okay, so let's try that. And here the slides are. Hey, awesome. I'm looking forward to hearing about 9 rules for creating fast, safe, and compatible Rust data structures in Rust. Thank you for being here. The stage is yours.
Thank you. So as Rainer said, I'm going to talk about creating data structures in Rust. These are lessons I learned creating a data structure called range set blaze, and we'll talk more about that. You can find the project and some of my other projects on GitHub, Carl K. And there's a longer write-up of this and some related articles on Medium, all for free, medium.com at Carl M. Cady. So just to review, what is a data structure? Why do we care about this? So a data structure is code that stores and organizes data in memory for efficient use later. If you use Rust, there's some data structures you're going to be very familiar with. An array is a data structure. So here we construct a data structure from 1, 2, 3, 4, 5. And along with constructing an array, we also have things like accessing the elements of array. Here we ask for the element in index position 2, and we verify that it's what we expect, 3. Another popular data structure in Rust is a vector. In this example, we create a new vector. We push the value 1 into the vector. We push the value 2 into the vector. So push is a method on the vector that modifies it. It has properties or methods we can ask about. So we can ask, what's the vector's length now? And we verify that the length of the vector is now 2. Another data structure that's also available in the standard library that's, I think, interesting is hash map. So in the example, we'll create a new hash map, and then we'll insert a key and a value. The key is the string topic, and the value is the string Rust. So we have an insert method. We can also do a search here. We can say, does the map currently contain the key building? And the answer will be no. So we've got a not sign symbol there, because right now the only key in the map is topic. So in general, we've got this memory that organizes data for us. And we often include operators like insertion, deletion. We'll often do a traversal. We'll want to see all the elements in a data structure, if that makes sense for our data structure. Sometimes we'll want to search for things if that's appropriate for our data structure. when you're coding yourself and you think about whether you want to create a data structure, one reason you might want to is it's a nice way to organize your code. It's a kind of sensible way that you can understand some bit of your code if it does have a kind of a coherent story about accessing data in a particular way. I also find creating, refactoring my code to pull out a data structure so it's its own thing, good for optimizing, because once I've done that, once you do that, you can focus on that data structure and think about ways to make it faster or more memory efficient, whatever is more appropriate for you. It's especially important if you've created some code and you think some way that you're manipulating the data would be interesting to others. If you want to share it, instead of giving people a whole bunch of your code and then saying, oh, here, find this and this and do this and this, like just functions. If you create a data structure, you can say, here's a thing that people can then try to understand. And it makes it easier to share because it makes it more comprehensible. I created the range set Blaze data structure, not for any of those reasons. I did it because I thought it was kind of range sets were kind of an interesting data structure. And I wanted to see how it was to implement it in Rust. I'd already done a previous version in Python. So I did it for fun. Maybe not always the best reason, but a good enough reason for me this time. Let's talk a little bit about the range set Blaze data structure. A range set itself is a sometimes useful but obscure data structure. The point of a range set is to represent a mathematical set. So in that way, it's like the standard Rust data structures like hash set or B-tree set, some set of elements. The difference with a range set is that it's restricted in the kind of things it can represent, and that internally it stores those things as a sorted disjoint list of ranges. So, for example, this could be information inside a range set. So we say we have the integers 100 to about 2,000, 20,000 something to about 30 million, and 105,013 to 101 million 16. So we've got three ranges. You can see I'm doing the inclusive version of Rust ranges. These few characters, less than 100, now represent more than 30 million individual integers. And you can see if your data fits into something like this, you can potentially save a huge amount of memory. And you can imagine that function and operations you might want to do, like set union and set intersection, are much more efficient in this in some form of this representation than they would be over the over 30 million individual integers. Here's an example of using the range set Blaze data structure. In particular, we'll construct a new range set called A from an array of ranges. We'll construct another one called B from an array of ranges, and then we'll do set union on the two of them. And here's a graphical representation of that, A and B, and we union them together, and we get C, and we can verify that C is indeed equal to minus 20, and 100 to 999 inclusive. So while I was creating the range set data structure, I kept in mind what I was learning about creating data structures and kind of formulated that into what could nicely be called 9 suggestions, but I wanted to be sound a little bossier, so I'm going to call them 9 rules. We'll go over all of them, some of them pretty quickly. And the rules will cover things like the importance of plagiarizing, designing your constructors, the iterators you'll need to create, what to do with illegal values and how to guarantee properties, some thoughts on defining operators, the importance of some just general things like good documentation, special importance, I should say, how to think about performance, and some of the issues having to do with testing. So let's now look at the rules one at a time. So the first rule is that you should plagiarize as much of your program interface, your documentation, and even your code as you possibly can. In particular, the standard library is a good place to plagiarize things for. So if your data structure is similar to something that's already in the standard library, in my case, I'm representing sets of integers. B-tree set in the standard library is also good at representing sorted sets. So I should plagiarize as much of B-tree set as I can. And the first step to doing that is to look at the documents for the standard B-tree set. When I look at it, I see that it defines 28 methods. So we can clear a B-tree set. We can take two B-tree sets and see if one is a superset of another. Also, and this surprised me, B-tree set, the standard B-tree set, implements 18 Rust traits. I would have guessed, I don't know, 2 or 3, but 18. And they're things like from iter, and we'll look at that a bit later some more. Given that it does support all these traits, I was surprised that it doesn't support a trait called set, mathematical set. Rust doesn't have any trait interface that represents a set. Instead, all of its set-like data structures kind of implement a hodgepodge of things, and they may or may not be exactly compatible with each other. So when we look at the B-tree set documentation, let's look at is superset. We can see that we get nice function signature, a nice description, and some examples that actually can be run. And most importantly, there's a source button here in almost all Rust documentation. When we click the source button, we'll see this code down here, which is the actual implementation of the library version of B-tree set. So what I did with range set Blaze, look at range sets Blaze documentation. I copied most of the function signature. I literally copied the documentation string here, and I even translated the example from the B-tree example to a Rust set Blaze example, and it's exactly otherwise exactly the same example. At the code, not only so by plagiarizing things from the standard library, you'll get a familiar starting design. So that's good for both you and for any users you have. You'll get free documentation and documentation tests. And in fact, you might even get free code. When I went and looked at the code for B-tree set for is superset between two things, self and other, I found out that all it does is apply is subset to other and self. And so in my implementation of is superset, I just did exactly the same thing. Another thing I got from plagiarizing here was looking at these attributes. The pound stable attribute turned out not to be relevant when you're creating your own library, but I wasn't really familiar with pound must use. I looked it up, kind of found out what it was about, and decided it was also appropriate for range set Blaze. One caveat is you don't want to plagiarize everything. Presumably, there's some reason that your data structure is different than the standard data structure, or you wouldn't be doing it. So, for example, B-tree set has a method called first that if the set is empty, returns none, and if it's not empty, returns the sorted first element of the set of elements, except it returns it a reference to that first element. Because range set Blaze only holds integers, I made my version of first to return the actual value and not just a reference to a value, because that seemed more performant. inappropriate for integers. Okay, let's go over to rule 2. You want to design constructors, excuse me, for ease of use, compatibility, and speed. You'll almost always want to construct a new and a default constructor. In my case, and in most set-related data structures, they would create an empty. They'd represent the empty set. I want to talk about some of the other constructors. If you construct a constructor from iter, here I'm constructing from an array of integers, then you not only get from iter, but you also for free can get collect, which can be useful for both you and your users. So if we construct a range set plays from this array with from iter, from this array with collect, we can verify that the two range set plays, things that we've created, are equal, and we can even print out what they look like. And range set plays can take things out of order and put it sorts them and makes them disjoint, gets rid of overlap. So it produces that. Generally, it's good to be permissive in what you accept in input. So here we've got redundant. The second example, we have redundant inputs. They're overlapping. They're not sorted. That's fine. Range set plays will take care of all the work to do that and put them in the canonical order that it represents them with internally. Just like from iter gets you collect for free, if you implement from, you get into for free. So here, kind of matching what B-tree set does, I accept from directly from an array or an array into, and you can get a range set plays, and we get the same values as we did up here with from iter. Whoops. Generally, you should be permissive in what you accept, but there might be efficiencies. If the user could promise me that the input that they're getting is already non-overlapping, that is disjoint and sorted, then I wouldn't have to do the work. The data structure wouldn't have to do the work to make them disjoint and sorted. So range set plays actually has a method called from sorted disjoint that takes an iterator where the things are already sorted and disjoint, an iterator of ranges, and get some efficiencies from that. But that's kind of a special case, and the user has to go through some extra work to guarantee that the iterator that's getting input really is has the guaranteed properties. We'll talk about that a little bit more on a later rule. Okay, rule 3 is just to be prepared to create more Rust iterators than you expect. So recall that in Rust and iterators, the thing that lets us do a for in. So example here, we create a range set plays from this, and then we do for value in the range set plays iter, and we'll get 1, 2, 3, 4, 5, 6, 8, 9, 11, 12, 13, 14, 15. In general, an iterator, when you create one, you create a new struct that implements a next method. And the next method, if there is no next thing available because you've run to the end of the iterator, it returns none. If there is a next value, it returns that value wrapped in a sum. So think to yourself, how many iterators do you think the standard B-tree set defines? Again, my guess would have been something like 3. But in fact, the standard B-tree set implements 8 iterators, iter and into iter, okay, 2, but it also has drain filter, something called range, and then 3 set-related ones, difference, symmetric difference, intersection, and union. Following the same kind of philosophy, range set plays also has a bunch of iterators, even more. It turned out I ended up implementing 13 iterators, which was a lot, in part because Rust, unlike languages that previously use, say, Python or C#, doesn't have a yield. and it doesn't make any guarantees about optimizing tail recursion, which means that when we implement a next method, we're doing a lot of looping or maybe some functional programming inside a loop. It tends to be low-level code. I find it kind of fun to write these iterators, but they're not particularly easy because of their kind of low levelness. They are efficient, so that part's good. And just to reiterate, then the lesson from Rule 3 is just kind of prepare yourself mentally for writing some of these iterator functions. We're mostly going to skip rules 4 and 5. You can get more details from the article. But just in general, you want to make illegal values unrepresentable. So for example, range set blaze only handles the integer types. It doesn't handle the character type. If a user tries to create a range set blaze of characters, there'll be a nice compiler error saying this isn't a type that is supported. And that's done via it implements its own trait called integer, and it checks that everything that gets that you try to put into it is part of that trait. Also, if appropriate, you want to guarantee properties. So I mentioned that we might want to have an iterator that we can input from that guarantees that things are already sorted and disjoint. There's a way, again, using traits in Rust to do that so that nobody can sneak in an iterator that doesn't have that property kind of accidentally. And the compiler will check if someone if someone tries to use the constructor that assumes the iterator is sorted and disjoint. If someone tries to put a different iterator in, it won't be allowed in because it won't have the right trait properties. Rule 6, in some ways, I found some of the most fun. Once you have a data structure, you can think about what operations and operators are appropriate for it, and then you can do anything you want. So given your data structure, you can ask yourself, does it make sense to define a plus operation between two instances of your data structure? Does it make sense to define the less than for it or shift? But you don't have to use any of these symbols. You can use these symbols to be anything you want. And in fact, there's 31 possible operators that Rust lets you define on your own data structure. And if any of them seem appropriate for your data structure, you can define them. The way you define them is, like most things in Rust, you define a trait and then a method inside that trait. So for example, I wanted vertical bar to be set union, this symbol. The way I do that is by implementing a trait called bit or. And why it's called bit or and not vertical bar is because, I don't know, vertical bar is usually used in Rust for bit or, but in this case, I'm going to use it for set union, and I just implement the bit or method, and then I'll get set union. You might wonder why I use vertical bar instead of plus sign for set union. Different languages, different data structure designers might have made a different choice there. I didn't have to make that choice. Following back to Rule 1, plagiarizing, I did what btree set and hash set did. They used a vertical bar for set union, so I used a vertical bar for set union, and I didn't think whether or not there was a better symbol for it because it was more important to be consistent. One thing you'll find out as soon as you implement something like vertical bar to be set union and then try to use it, you'll find out it doesn't work everywhere you want, because you don't really just want set union between two owned instances. You also want set union between two references, between a reference and an owned, and between an owned and a reference. So because of that, instead of implementing each of these once, you actually want to implement them 4 times. There is a nice crate, GenOps, that can help streamline that. So you really do only have to implement it once if you want to use it. Rule 6 is kind of Rule 7 is kind of a meta rule, and that's follow a different set of 9 rules, the 9 rules of good application program interface design. That's another article. 6 rules from that article especially apply, and the most important one is to write good documentation, and not just to help your users so they understand your data structure, but to keep your design honest. There's nothing more important than writing documentation and then getting to the point where you're telling a user, oh, be sure you do this before that or it won't work. Watch out for this. And then deciding man, this is so embarrassing. This is so hard to explain. You know what? I'm just going to fix the data structure to simplify it so it'll be easier to explain. Likewise, so you should have documentation on every public thing that you create in your data structure, and you should have an example on almost every bit of documentation that you write. And if you find yourself going, man, I can't write an example here because all the examples would be too long to even get started, then that's another sign that you need to fix your design so that simple things are simple. And again, keeping you honest. Some other tips of good application program interface design is to always use Clippy, to try to accept as many types as you can. If you're accepting a path, also accept the path buff and a string and a stir. Where appropriate, make sure you define and return nice errors. Interestingly, a lot of data structures don't return any errors. The standard B tree set doesn't have any error type, because if you give it it accepts most things, and if you give it something it really can't accept, it just panics. And another good rule from that article was know your user's needs, ideally by eating your own dog food. That means you really shouldn't create a data structure that you don't need and don't try using yourself. I'll confess that because I was doing this one for fun, I didn't follow that rule, but it's still a good rule. Rule 8 is optimizing your performance using representative data, criterion benchmarking, and profiling. So ideally, you have some real world data that you can put through your data structure and tell whether or not users are going to be happy using your data structure with its performance. In this case, I didn't have that, so I did the next best thing, which was to create synthetic data. One synthetic bit of data was just generating, say, over a range of 1 million integers uniformly. And as you can imagine, some number of integers. As you can imagine, the standard libraries set data structures, hash set in particular, is quite good at taking a bunch of integers that are just uniform. And in fact, range set plays is pretty bad when the integers that it's given to manipulate are distributed uniformly over a wide range. So it's about 2.5 times worse than the standard library under data that's generated that way. So you might think that's discouraging, but no, because the other way that I thought was interesting for generating data was generating data where instead of generating individual integers, I generate ranges of integers randomly over a big range, and then give them to the data structure's constructor, one integer at a time. So we'll call those clumpy integers. And in that case, range set plays is 10 to 30 times faster than the standard library on manipulating those integers. And if we're willing to give it the integers as ranges instead of as individual integers, it's hundreds of times faster. So with these two kinds of data, I was both able to give users kind of an honest assessment of a worst case performance and make sure it was running fast for the conditions that it was really designed for, which is what I'm calling the clumpy integers. To measure the performance of things, you'll want to use the criterion crate. Criterion is the most popular benchmarking crate in Rust. I found it nice. I actually think it was smarter than I was. I had these big, long benchmarks that took a long time to run, and criteria would tell me that it really wanted shorter benchmarks. And I thought, I want a long one. And I decided criterion was right. So my general advice is don't fight criterion. If you give it the kind of quick runs that it expects, it can generate all kinds of meaningful and important statistics for you pretty much automatically. You can use the benchmarking to drive algorithm design. Range set Blaze isn't the only range set crate available for Rust. There's several. I benchmarked them all. Maybe not all. I benchmarked many of the candidates. Some of them represent this list of sorted and disjoint ranges in a vector, and some of them represent it in some kind of tree. It turned out that the fastest one that used a vector was 14 times slower than the slowest one that used a tree. So that helped me know that I wanted to use a tree to represent the list of ranges. And that allowed range set Blaze to be 50 times faster than the fastest vector-based data structure, thanks to benchmarking. I knew to make that design. Profiling is another thing you can do. You can try to find the function or functions that are taking the most of your time in your data structure and doing its operations. Flame graph is the most popular tool in Rust for doing profiling. I find flame graph a little bit limited. I was used to C++ style profilers like the licensed Visual Studio. AMD has one. And I actually found out that since these profilers just work on executable code, they don't care whether the code was created by C++ or Rust. So I used Visual Studio to do profiling, although in this case I didn't really find anything particularly interesting. But flame graph is easy to use and free, so that might be a good place to start. And a final rule, let's talk about testing. You want to test coverage. You want to test all the examples in your documentation. You want to test that you've implemented expected traits. You want to test that if you're giving compiler errors, like if a user puts in the wrong type for your data structure, that you're giving that they'll get a sensible compiler error. And to the degree you can, you want to check that your data structure does the right thing, that it's correct, because your users will be depending on it. Here are just a few tips along those lines. One is I used LLVM Cove to measure coverage, but I also tried coverage is making sure that every line of your code is actually executed somewhere by a test. You often find yourself creating new tests. I decided to also put those new tests in my integration test folder. Integration tests are tests that only use your public methods and objects. And so by adding additional coverage tests as integration tests, that also gave me another chance to exercise the public methods of my data structure. Doc test by example. You should always test your examples in your documentation or they'll be wrong almost instantly. One way you can check correctness, a kind of an interesting way, is with a Rust tool called Quick Check. If you know that some of the operations of your data structure should give the same answers as the operations on a standard data structure, for example, if we're representing sets of integers and we want to know if two sets are disjoint, then btree set and range set Blaze should agree on when they're disjoint and when they're not disjoint. And Quick's check is a very clever testing mechanism that puts in cleverly random examples, and will feed them to both data structures and give you an error if it finds any inputs that give divergent outputs. I'm not going to show it, but it's in the article. I also encourage you to test across many or all the types that you support. Yeah, I talked about testing for many traits, missing traits, like you forgot to put clone in. There's a way you can look for that, and testing for illegal values. But I'll leave that to the article. So in conclusion, if you want to create a data structure, Rust is a great language for creating fast and almost likely correct data structures. If you do decide to do it, I encourage you to follow the 9 rules. As a follow-up, you can see the article that this talk's based on Medium at Carl M. Cady. There's also some other follow-up articles porting the data structure to the web and to embedded processors, formally proving some of the arithmetic operations that the data structure uses, using Kanna, I'm not sure I'm pronouncing that right, and even formally proving one algorithm's correctness using a different tool called Daphne. And finally, published just last week, an article about accelerating some of the operations in ingesting a bunch of integers with SIMD operations. And with that, I am done.
Awesome. Thank you, Carl. Thank you very much. I really, really enjoyed your presentation. I love that. I also love coding for fun. For me personally, I find it awesome that you take the time and sit down and for fun build something like that. I think this is great, and a lot of people will maybe or probably use your data structure and benefit a lot from it.
I actually got a user request for a new feature 3 or 4 weeks ago,
really?
and I said, "Oh my goodness, that means people are actually using this."
Now you are in maintenance mode.
Yes.
Very nice, very nice. So people in the chat, keep your questions coming. I would like to kick off the round with one question in particular. Data structures like the vector, they offer accompanying macros, which make it particularly easy to write certain scenarios. Did you ever think about offering macros? Did you see a need, a use case where you make it easier to consume your data structure by providing some additional macros?
That is an interesting idea. I don't think that the standard data structures I was modeling off of, B-tree set and hash set, have any macros like that. I, of course, use the vector ones all the time. So I would have kept that in mind. If I'd thought of that, if I'd seen that being used, and if it was one of the easy macros to define, then I certainly would have done it. I actually have another article on writing the more complicated kind of macro. Those are always a lot of work, even if you do all the right things. So I would have pulled back before doing that and said, well, here's another thing, finished is good. So, wait until you see whether users are really asking for things and where the use is going, and then think about what to add.
Yeah, got it. I think that B-tree set does not have particular macros for making it easy, but maybe I'm wrong. I know about the vector thing, and this brought me to this question. I really like the work that you do by taking a step back and talking about some design guidelines. I can very well remember the time when I was doing C# work, and there was this book about framework design guidelines where you had a lot of guidance of how to build things. And I think that is particularly important and valuable from your work. Thank you for that. Not just the data structure that you created, but also telling people about what's important to do when you create something like this. So this is super interesting. My last question would be, did I understand that correctly? Your data structure already works in WebAssembly?
Yes. Yes, I got that was kind
Awesome.
of funny. I got a user request to make it work without the standard library. So that became a project in another article. The user really didn't need it to work on embedded systems, no stand, no stud. They really just needed it in WebAssembly. So if you do it no stud, it'll definitely work in WebAssembly, but it turns out you don't have to go through all that work. Most WebAssembly will work, you can go halfway and it's quite a bit easier, but I went all the way and it works fine in WebAssembly. It's kind of cool to see it working, actually executing inside a web page.
Nice.
And
Very,
it does,
very
and
nice.
it does work on embedded processors too, although I don't know the application for that, but it works.
Maybe. Wait for the next user request.
Yeah.
Definitely. We have a question from the audience. Can I show it to you? It says, you mentioned an article in the presentation. Was it shared already, or did the viewer miss the link? Do you know which article is referred to? I think you mentioned an article multiple times. If you have a link for us, you can share it.
I will get the link.
Oh, perfect. If you want, you can put it in the private chat, in the comment section, in the private chat, or you can write it. I'm not sure if you can do that directly in the YouTube chat, whatever you prefer. You can also share it using the screen, whatever works best for you.
Okay, I've got the link. Let me put it in the private chat.
Perfect, and I will take it. Thank you very much. I will take it from the private chat and put it in the comments. So I hope I did the correct one. Yeah, here it is. I put it in the comments. So the answer, Arcus, to your question is now in the comment section in the chat, and you can get it from there. So yeah, Carl, thank you very much. It was super interesting. A little story to the side. I teach at the local vocational college for computer science, and currently my students have to learn about dynamic data structure. Maybe I have to make them watch your video, because it is it will be super interesting for them. Some of them think it's so easy to build a data structure like that, and I bet it will be a bit of a surprise for them to hear from you what it takes to build something like that professionally.
Yeah, I mean, you don't want it to just be barely working for yourself. If you want to make an artifact that's useful not only for other users but yourself in the future and other applications, it's worth taking some of the extra steps and putting the care into the design.
Yeah, absolutely. Yeah. So thank you, Carl.
Thank you.
Enjoy a nice day. Have a nice day. For you, it's in the morning. For us, it's now in the evening. So I think with that, I say thank you and goodbye to the US, and I hope you will visit us again. You're always welcome here at Rust Linz.
Thank you, Rainer. Thank you, everyone.
Thank you. Have a nice evening. Very nice. So we are at the end of today's Rust Linz session. I think that Ivan, if I understood correctly, Stefan talked with Ivan. Ivan will fix the demo, and we will record the rest of the demo in the next few days, and we'll put it on the YouTube channel, so you have a complete presentation where you do not just see the amazing steps leading towards a potential solution, but where you see the end with a working solution finally on our YouTube channel. So please take a look. The Rust Linz meetups videos are on the official Rust YouTube channel. So check out that one. If you follow that one, you will definitely see the video. With that, I would like to repeat my thanks to the speakers. I think those both did a great job. We had 2 interesting sessions today. I would like to say thank you to all the visitors for visiting us here virtually. And I want to close by saying have a Merry Christmas, have a good start into the new year, and definitely Rust Linz, we will continue in the next year, hopefully in January. Subscribe to our Meetup page so you will be notified when we know when we are going to start with the next Meetup. With that, Merry Christmas, have a nice New Year, and see you all in January 2024. Goodbye.